Good evening. Welcome to the QCIS channel. Where on this channel, you get a daily dose of science, technology, engineering, and math. My name is Leon Jones, and I'm going to get right into it. The topic is going to be project cost and cost management. That's the title, project cost and cost management. Now, what is the difference? Well, when we deal with cost is monetary. And what goes into cost? Labor, your equipment, and your materials. Now, when we deal with the cost management, it's the process of managing the cost to ensure that the project is completed on time and under budget. And with construction, there are a lot of costs. Again, I name you the main three: materials, equipment, and labor. Those are the main three. Now, there are other costs as well. There's insurance you have to worry about. Some of the contractors pay design costs, inspection costs, you know it. But all those costs are basically built into unit cost contracts. Yes, there's front loading and there's a retainage, generally a 10% retainage, just to gather everything for the as-builts. But when we deal with costs, starting off with cost, construction is a cost itself. Construction, although it's an industry, it's a liability. And one of the costs that are associated with construction are fatalities, ocean fines. They're also costs. Liquidated damages. Those are costs that you don't hear about. Late in defect. But I'm going to get into tonight. Going to turn it up. I am going to talk about construction project cost management. So basically, I just took cost management, put them together because it's all under project management. Now, what is cost and project cost management? Well, again, cost is a resource sacrificed or foregone to achieve a specific objective or something given up in exchange. Now, as I stated before, costs are usually measured in monetary units like dollars. Now, project cost management includes the processes required to ensure that the project is completed within an approved budget. Now, when we talk about the basics of cost management, well, most CEOs and boards know a lot more about finance than IT. So IT project managers must speak their language. So when I told you about accounting, well, we deal with profits. Well, basically a profit is a revenue minus expense. And we also have life cycle costing, which I'm going to talk about project lifestyle next week. Well, when we deal with project lifestyle costing, it's basically estimating the cost of a project plus the maintenance cost of the project it produced. Well, basically, projects have a lifestyle. It goes from the design to pre-construction to construction phase to project closing. Then you get into the operation and the management phase. And then once the project reaches its climax, it's either going to be remodeled or demolished or another project. But again, we're going to deal with project lifestyle, project life cycle next week. But as I continue, part of cost management, again, we deal with life cycle costing, and that is basically estimating the cost of a project plus the maintenance cost of the products it produces. Then we deal with the cash flow analysis, and that's basically determining the estimated annual cost and benefits for a project. Now, benefits and costs can be tangible or intangible, direct or indirect. Then we have what we call a sunken cost. And a sunk cost should not be a criteria in project selection. Now, tangible costs or benefits are those costs or benefits that an organization can easily measure in dollars. And we deal with intangible costs or benefits. They're costs or benefits that are difficult to measure in monetary terms. Now, when something is tangible, you can pick it up. When something is intangible, it's basically a service. That's why it's very difficult to measure in monetary terms, because you're basically going to be charged a fee. You're going to be billed for something. Like if a contractor or a client uses an engineering firm, that is going to be an intangible cost. Now, a tangible cost is going to be the cost of the equipment. And then we deal with direct costs. They're costs that can be directly related to producing the products and services of the project. Then there are direct costs. They're costs that are not directly related to the products or services of the project, but are indirectly related to performing the project. And then we deal with money in the past. It's known as a sunk cost. Money that has been spent in the past when deciding what projects to invest in or continue. You should not include sunken costs when bidding on a project or cost of a project. Now, we also talk about the learning curve theory, and that states when many items are produced repetitively, the unit cost of those items decreases in a regular pattern as more units are produced. And reserves are dollars included in a cost estimate to mitigate cost risk by allowing for future situations that are difficult to predict. So under reserves, they are contingency reserves, which allow for future situations that may be partially planned for or sometimes called known unknowns and are included in the project cost baseline. You have your management reserves. Management reserves allow for future situations that are unpredictable, sometimes called unknown unknowns. So you have under contingency, known unknowns, and under management, and these are reserves, you have unknown unknown. Types of construction costs. Again, types of construction costs. Deal with capital costs, expenses related to the initial establishment of the facility. Again, we are talking about types of construction costs. I just gave you capital costs. Capital cost again, it's expenses related to the initial establishment of the facility. Now, what is involved with that? You're going to have land acquisition, and that includes assembly, holding it, and improvement, planning and feasibility studies, architectural and engineering design, construction, including materials, equipment, and labor, field supervision of construction, construction financing, insurance and taxes during construction, owner's general office overhead, equipment and furnishings not included in construction. And then there is inspection and testing. Now, when we deal with O&M, which is operating and maintenance costs, that's the operation and maintenance cost in subsequent years over the life cycle. That includes the following expenses: land rent, if applicable, operating staff, labor and material for maintenance and repairs, periodic renovations, insurance and taxes, financing costs, utilities, owner's other expenses. Now, the magnitude of each of these components depends on the nature, size, and location of the project, as well as the management organization, amongst many considerations. Now, the owner is interested in achieving the lowest possible project cost that is consistent with the investment objectives. We talk about contingencies, provisions. Now, in most construction budgets, there is an allowance for contingencies or unexpected costs during construction. Now, the contingency amount may be included with each cost item, and it may be included in a single category of construction contingency. Now, the amount of contingency is based on historical experience and the expected difficulty of a particular construction project. Now, for example, we have one construction firm that makes estimates of the expected cost in 5 different areas: design development changes, schedule adjustments, general admission or general administration charges. That is general administration charges. And what's included with that, wage rates. Then you have differing site conditions for those expected and third-party requirements imposed during construction, such as a new permit. Again, 5 different areas: design, schedule adjustment, and in that design are going to be developing changes, general administration changes, such as wage rates, differing site conditions for those expected and third-party requirements imposed during construction, such as permits. Project cost management. Now, we dealt with first 9 slides, we dealt with cost. Now we're going to get into project cost management. Now, that includes the processes involved in planning, estimating, budgeting, and controlling costs so the project can be completed within the approved budget. Then there's cost estimating, developing an approximation of the cost of the resources needed to complete project activities. Then there's cost budgeting, which is aggregating the estimated cost of individual activities or work packages to establish a cost baseline. Then there is cost control, which that is influencing the factors that create cost variances and controlling changes to the project budget. Now, cost estimating, this is one that you see quite frequently, the tools and techniques. Now, you have your analogous estimating, and that's basically using the actual cost of previous similar projects as the basis for estimating the cost of the current project. Now, analogous cost estimating uses expert judgment. Also, analogous cost estimating is frequently used to estimate cost when there is a limited amount of detailed information about the project. Again, analogous cost estimating is frequently used to estimate cost when there is a limited amount of detailed information about the project, and it's generally less costly than other techniques. Now, when something is cost. When a cost estimate is less costlier than other techniques, you better start to check the accuracy. Because generally, when we deal with analogous estimating, it's going to be less accurate. Because why? Because you're basically taking something from another project, which that's the project, another project's cost. And that project is similar to the current project. Well, projects are all different. They may be similar when it comes to size and scope, but I have never, in my 30 plus years in the construction industry, run into projects that are exactly alike or even similar, because different environmental considerations, permits, more change orders, less change orders. Those are examples. Now, we also determine resource cost rates. Now, for each resource to estimate schedule activity costs, again, for each resource to estimate schedule activity costs. And we have standard rates with escalation factors that can be included in the contract. Then we can obtain data from commercial databases, and seller published price list is another source of cost rates and gathering quotes. Now, the obtaining data, well, there is a website called RS Means. RS Means is one of the oldest tools for estimating the cost of contracts. Now, back in the days when I used RS Means, you had a book every year. And you would look in that book to determine equipment, and everything is updated every year with RS Means. RS Means is still around. However, it's in the database. Now you have other sources as well, but RS Means is one of the big tools. Bottom-up estimating. Now, this technique involves estimating the cost of an individual work packages. Again, this technique involves estimating the cost of individual work packages or an individual schedule of activities with the lowest level of detail. Now, the cost and accuracy of the bottom-up cost estimating is typically motivated by the size and complexity of the individual schedule, activity, or work package. Now, generally, activities with smaller associated effort increase the accuracy of the schedule activity cost estimates. Then we deal with parametric estimating. And that is a technique that uses a statistical relationship between historical data and other variables. Example, square footage in construction. Now, this technique can produce higher levels of accuracy depending upon the sophistication as well as the underlying resource, quantity, and cost data built into the model. Now, a cost-related example involves multiplying the planned quantity of work to be performed by the historical cost per unit to obtain the estimated cost. Now, how do we get all these costs? Well, you can get cost a few ways, but you have to look at the plans. You need to know your units, your linear feet, square yards, square feet, cubic feet, each. Now, you have project management software, but what if you don't have project managing software? What I do on the plans, because as an estimator, you are basically building the project from the plans but you're working out the cost and its approximate cost to build a project. Now, I always believe in this. Learn how to do it by hand before you actually use the project management software. Then you go to a spreadsheet. Now, there is project management software such as cost estimating software applications, computerized spreadsheets, and simulation and statistical tools that are widely used to assist with cost estimating. And we have our vendor bid analysis. The cost estimating methods include vendor bid analysis and an analysis of what the project should cost. Now, in cases where projects are won under competitive processes, additional cost estimating work can be required of the project team to examine the cost of individual deliverables and derive a cost that supports the final total project cost. And there's the reserve analysis, because most cost estimators include reserves, also called contingency allowances, as cost in many schedule activity cost estimates. Now, there has the inherent problem of potentially overstating the cost estimate for the scheduled activity. Cost budgeting. That involves aggregating the estimate cost of individual scheduled activities or work packages to establish a total cost baseline for measuring project performance. We get into cost aggregation, and that's scheduled activity cost estimates are aggregated by work packages in accordance with the WBS. What is WBS? It stands for Work Breakdown Schedule. Then you have the reserve analysis, and that establishes contingency reserves, such as the management contingency reserve, that are allowances for unplanned but potentially required changes. Now, such changes may result from risks identified in the risk register. Again, such changes may result from risks identified in the risk register. Then you have funding limit reconciliation, and that is large variations in the periodic expenditure of funds are usually undesirable for organizational operations. Therefore, the expenditure of funds is reconciled with the funding limits set by the customer or performing organization on the disbursement of funds for the project. Now, we have cost budgeting outputs. We start with the baseline. Now, the cost baseline is a time phase budget that is used as a budget against which to measure, monitor, and control overall cost performance on a project. And this is what you have here. Time and cumulative values. And here's your expected cash flow. Now, project funding requirements. Well, funding requirements total and periodic, whether annual or quarterly, are derived from the cost baseline, and they can be established to exceed usually by a margin to allow for either early progress or cost overruns. Funding usually occurs in incremental amounts that are not continuous, and therefore they appear as a step function. And that's what you have here. This is a step function. You have your cost baseline right here, and then you have your expected cash flow and your funding requirements. And this is what we call our step function. Cost control. Well, see this a lot. Project cost control includes influencing the factors that create changes to the cost baseline. And it also includes ensuring requested changes are agreed upon. And it's managing the actual changes when and as they occur. Also showing the potential cost overruns do not exceed the authorized funding periodically and in total for the project. Then there's monitoring cost performance to detect and understand variances from the cost baseline. And then there's recording all appropriate changes accurately against the cost baseline. And then with cost control, there's preventing incorrect, inappropriate, or unapproved changes from being included in the reported cost or resource usage. Then there's the informing appropriate stakeholders of approved changes. Then there's the acting to bring expected cost overruns within acceptable limits. Now, cost control inputs. There's the cost baseline, the project funding requirements, performance reports, work performance information, approved change requests, and a project management plan. Then cost control, we get into tools and techniques. So we have the cost change control system. And a cost change control system is documented in the cost management plan, and it defines the procedures by which the cost baseline can be changed. And under performance measurement analysis, well, it's basically techniques to help assess the magnitude of any variances that will invariably occur. Then you have the EVT, which is the earned value technique, and it compares with the cumulative value of the budgeted cost of work performed or earned at the original allocated budget amount to both the budgeted cost of work schedule plan and to the actual cost of work performed actual. And this technique is usually useful for cost control, resource management, and production. Then under cost control tools, again, we have our cost control system, a cost change control system documented in the cost management plan defines the procedures by which the cost baseline can be changed. It includes the forms, documentation, tracking systems, and approval levels necessary for authorizing changes. Then under performance management analysis, again, it's techniques that are utilized to help assess the magnitude of any variances that will invariably occur. The earned value technique compares the cumulative value of the budgeted cost of the work performed at the original allocated budget amount to both the budgeted cost of the work schedule to the actual cost of the work performed. This technique is especially useful for cost control, resource management, and of course, production. And I actually gave you that slide twice because it's very important. Then we get into our earned values measurement. That involves developing these key values for each scheduled activity, work package, or control account. It is a method measuring project performance by comparing the amount of work planned with actually accomplished in order to determine if the cost and schedule performance is planned. Now, we have our acronyms. We have scheduled work, budgeted cost of work schedule, PV, earned value, budgeted cost of work performed, actuals, actual cost of work performed, AC, authorized work. Term is budget at completion. The acronym is BAC. Forecasted cost, estimate at completion, EAC. Work variance, schedule variance, SV. Cost variance to term cost variance, CV. And completion variance, VAC. Now, variance calculations. Well, Under variance calculations, we have CV, which is cost variance. Now, CV equals earned value minus the actual cost AC. So what we're dealing with is the cost variance at the end of the project will be the difference between the budget at completion and the actual amount spent. So the formula is CV equals EV minus AC. Now, if you have a negative value of CV, which is your cost variance, that would mean that you have an overrun. As I move on to the schedule variance, SV equals earned value minus schedule variance, and that will ultimately equal zero when the project is completed because all of the planned values will have been earned. So the formula is SV equals EV minus PV. And again, just as we stated with cost variance, when there is a negative SV, just like we had a negative CV, would mean time overrun. Performance indices, CPI, that's your cost performance index. So a CPI value less than 1 indicates a cost overrun of the estimates. Now a CPI value greater than 1 indicates a cost underrun of the estimates. So we have a formula. CPI equals EV divided by AC. CPI is the most commonly used cost efficiency indicator. Formula for CPI, again, is EV divided by AC. And then you have your SBI. The SBI is used in addition to the schedule status to predict the completion date, and it is sometimes used in conjunction with the CPI to forecast the project completion estimates. Now, again, you don't see CPI as much as, SPI as much as CPI. But when CPI is used, it's basically in addition to the schedule status to predict the completion date, and it is sometimes used in conjunction with the CPI to forecast the project completion estimates. Now, CPI equals the ratio of the EV to PV. Formula, SPI equals EV divided by PV. And the estimated completion, the AC equals AC plus ETC. Estimate to complete, which is ETC. ETC equals the revised estimate for the work remaining. And on this curve, the earned value technique in its various forms is commonly used, and it's basically performance measurement. So what we're doing here with this graph, we're using what we call the EV, the earned value technique. It is a commonly used method of performance measurement. Why? Because it integrates project scope, cost, and schedule measures to help the project team assess project performance. And here's what it looks like. You have your actual cost, your earned value, your planned value, and then you have your budget at completion. And one thing you have to understand there is cost and schedule forecasting. So there are a couple of exercises. Exercise 1, and we're going to deal with a schedule variance example. So we have PV that equals $42,000, EV at $38,000, and AC at $48,000. So budget at completion, BAC equals $80,000. So to find our SV, we need to subtract PV from EV. So what we have here, we have our SV or EV at 38,000 minus our PV at 42,000, and then we get a negative 4,000. So in percent, remember when we have SV EV, when there's an overrun, there's a negative, and this is what you're going to have in this problem. No, you're not going to use absolute value. You're going to use negative. And when you take the equation, you plug in the numbers, you're going to get a negative percent, negative 9.5%. Hence, there is a schedule overrun. Now, when we get to the cost variance example, we have CV equals EV minus AC. So, guess what? Don't take the numbers, you plug them in just like we did for the schedule variance. And when we utilize a formula, again, we come out with a negative number. So we have what we call the variance, which is always in a percent. We have a 26% overrun, which usually you're looking at a change order. Now, some, depending on what type of project, I know on DOT could be between 5 and maybe 20%. You don't need a change order. Anything over that, you have to get a change order. We can move money around. All right, cost performance index. CPI equals EV divided by AC. So you have 38,000 divided by 48,000, get 0.79. Well, what does that mean? Well, that means for every $1 spent, you get 79 cents work. That's what that means. Now, when we have our schedule performance index, we end up with 0.90. That means 90.90 worth of work has been for each dollar worth of work that has been planned to be done. So, in other words, we can say 90 cents worth of work has been for each $1 worth of work that was planned to be done. And we have our estimate at completion and variance at completion. So go ahead and plug in the numbers. And what do we have? Well, we get $101,265 for the EAC. Okay, we're gonna plug that in, and guess what? We get another negative number. You're dealing with construction. Anything that's a negative number means you're going to exceed or there's going to be an overrun. And in construction, you have to manage overruns. All right, problems. You have BAC equals 40K, EV equals 20K, PV equals 28K, AC equals 26K. So what you have to do, you have to determine the percentage of work scheduled. Also, you have to determine the percent of budget spent, the cost variance, and the schedule variance. So, case one, PV equals 16,000, EV equals 16,000, AC equals 16,000. Ideal case where everything goes as planned. Then you have case two, PV equals 19,000, EV 15,000, ACP 17,000, which that is 400, which is 400, I'm going to say dollars worth of work, and it's behind schedule. Why? Because your SV is going to be negative. 15 minus 19 is going to be a negative 400. Of course, your SV is going to be minus 21%. Your CV is going to be minus 200. So that's an overrun by 200. Your CV percent minus 13. But your SPI is 0.799 and your CPI is 0.88. Unit cost method of estimation. Now, this is one that's very, very common. Now, if the design technology for a facility has been specified, the project can be decomposed into elements of various levels of detail for the purpose of cost estimation. Now, the unit cost for each element in the bill of quantities must be assessed in order to compute the total construction cost. Now, the concept is applicable to both design estimates and bid estimates although different elements may be selected in the decomposition. Now, for design estimates, the unit cost method is commonly used when a project is decomposed into elements at various levels of hierarchy as follows. So we get what we call a computer aided cost estimation, a computer aided cost estimate, a computer aided cost estimation. Again, we get a computer aided cost estimation. Now, some of the common features of computer aided cost estimation software includes, now again, we're not dealing with an estimate that we have to do by hand. Now, if you really want to get into the estimation process, start off with a smaller project, but under computer aided cost estimation, everything is going to be inputted by utilizing a computer. So again, some of the common features of computer aided cost estimation software include databases for unit cost items such as worker wage rates, equipment rental, or material prices. Now, these databases can be used for any cost estimate required. So if the rates change, cost estimates can be rapidly recomputed after the databases are updated. Now, databases of expected productivity for different components, types, equipment, and construction processes. Again, databases of expected productivity for different component types, equipment, and construction processes. That's under computer aided cost estimation. Then you can import utilities from computer aided design software for automatic quantity takeoff components. Alternatively, special user interfaces may exist to enter geometric descriptions of components to allow automatic quantity takeoff. Then you can export utilities to send estimates to cost control and scheduling software. This is very helpful to begin the management of costs during construction. Now, version control allows simulation of different construction processes or design changes for the purpose of tracking changes in expected costs. And then there are provisions for manual review, override, and editing of any cost element resulting from the cost estimate system or cost estimation system. Then there are flexible reporting formats, including provisions for electronic reporting rather than simply printing cost estimates on paper. And then you have archives of past projects to allow rapid cost estimate updating or modification for similar designs. Now, components of project cost estimates for major projects. Well, there is what we call preliminary engineering. This is the cost to prepare the construction documents. Now, what are the construction documents? Your plans and your specifications, probably your special provisions. You're going to use the preliminary engineering to establish the contract. And you have your right-of-way. This is the cost to research and acquire right-of-way for the project, including easements, include right-of-way costs for stormwater management, wetland mitigation, and other work outside the roadway prism. And then you have external third party, example utilities and railroad adjustments. Perhaps the most difficult cost estimate to estimate are those associated with third parties such as utilities and railroads. And that is one thing when you're out there doing construction. This is why some of these projects, when you deal with utilities, because you have to sometimes relocate utilities, and then you also have to deal with the railroad. Again, you're dealing with an external third party, which the example here is utilities and railroad adjustments. And again, These can be the most difficult costs to estimate. And why? Because they're associated with third parties such as utilities and railroads, and using software to assist in cost management. Now, I did mention this early. Spreadsheets are a common tool for resource planning, cost estimating, cost budgeting, and cost control. More companies use more sophisticated and centralized financial application software for cost information. Project management software has many cost related features. And again, when we deal with costs, we look at labor, we look at materials, we look at equipment. There's variable costs, there's fixed costs, direct costs, indirect costs. And when we deal with cost management, what we're doing is we're looking at a process so we can manage the cost to complete a project under budget and on time. And that concludes this topic on project construction cost management. If you like what I just presented, please comment, share, and subscribe. And if you're looking for some political and some social content, you can check out my main channel, a 411 Talk Zone radio show channel. Now, here's where you can find me. Once I complete my recording of all of my videos on YouTube for the 411 Talk Zone radio show channel, I will upload the videos, of course, to YouTube, and I will also upload the video. Now I'm on Rumble for the 411 Talk Zone radio show, and I'm on Truth Social, and I upload the videos to X, formerly Twitter. So I go through 4 different platforms for the 411 Talk Zone radio show, and I go through 2 different platforms for the QCIS channel. They are X, formerly Twitter, and LinkedIn. Once again, thank you for listening and viewing this content on construction project cost management from the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. Till next time, my name is Leon Jones. I want you all to have a wonderful and gracious evening.